All right, in our last video, I multiplied fractions and we talked about reducing fractions. Let's talk now about dividing fractions, okay? Very similar, okay? We have one little extra, thing to worry about, trick, if you will, or procedure, not trick, procedure. Let me get my screen all set up here. My apologies. Not being Johnny on the spot. Okay. All right, so that's pretty good. Dividing fractions, all right? It's, generically presented here, some A over B divided by C over D. The generic presentations always make it look more difficult. The first fraction stays the same. We change the divide to multiply, and then we take what's called the reciprocal of the second fraction. Now, I call it the old flip-flop. We flip it over, D over C. And we multiply. How do you multiply a fraction? Multiply across the top, multiply across the bottom, reduce as needed. All right, so that's all we're going to do. Let's do it. Let's try 2/3 divided by 7/15. We leave the first fraction alone, and we get a pen that works. Boy, I'm batting 1,000 here tonight. This is actually, I'm making these videos at various times. This is the first video I'm making on a given night, so I'm just starting off. So I'm batting 1,000 starting off tonight. We're going to change the divide to times. There's another botch, and we're going to flip this guy over. Okay, so 2/3 times 15/7. Now remember what I said. You can physically multiply it and get 30 over 21, and when the numbers are small, it doesn't kill you to do that. But now I have to reduce. How do I reduce 30 over 21? Well, I have to factor. Call that 10 times 3 is 30. 7 times 3 is 21. And that reduces to 10 over 7, which I might want to call a mixed number. Okay. Had I chosen not to do that, nothing immediately cancels. Okay. Now, if you have kind of the mental cancel, there's a 3 hidden in that 15, and you just want to cross it out and say, okay, that's now a 5 because I divided by 3. That's fine. If you want to just say, okay, I'm going to factor that 15 and call it 5 times 3, so I've got this on my hands here, so now I can clearly see those 3s. That's fine, okay? Any number of ways to do this kind of problem, all right, as far as the reducing goes. But the key here to dividing is we're going to change the divide to multiply. We're going to flip that second fraction over and multiply and reduce, okay? All right, so what about something like this? 3/4. Now what if I have to divide a fraction by a whole number? Uh-oh, seems like it's a different procedure, but of course it's not, right? Because any whole number, I can slap an old denominator of 1 under there, and now it's a fraction divided by a fraction. Leave the first fraction alone, change the divide to times, do the old flip-flop, multiply across the top, multiply across the bottom, reduce as needed. This one I don't need to reduce, and there we go. Okay, what about a mixed number? Well, there's really no easy way to do a mixed number. Okay, we kind of really need to turn them back to improper. So 16, 17, 18, 19/4 divided by, that'll be 3/2, which is 19/4 times the old flip-flop, 2 over 3. And I can see that 2 hidden in the 4, and I know you can also, okay? Generally speaking, I like to just show the process of factoring just to really spell it out. I took that 4 and I called it 2 times 2. Now I can see those 2's. 19 over 6. Again, we could turn it into a mixed number. Maybe because this one started as a mixed number, the answer probably will be a mixed number if this were a problem, right? So you say 6 goes into 19, 3 times? We get the 18. We subtract and get a remainder of 1. So it's 3 and 1/6. Okay. All good. Now you say that's fine and dandy there, Cooper, but speed. We're taking a test here. We don't have time to mess around. Yeah, I know. I hear you. Let's do this one on the calculator. Remember our fraction button here. It's a mixed number button. 4 fraction button, 3 fraction button, 4ths. Okay, it looks strange, but that's how this calculator looks. That's 4 3/4 divided by 1 fraction button, 1 fraction button half equals, bada boom, 3 and 1/6. Okay, and again, that's how it's looks on that screen. All right. Multiply and divide, knocked out. What about adding and subtracting fractions? Well, we need this little thing called a common denominator to add and subtract fractions. And the reason we need that, you know, if I have this problem here, and I want to add these two fractions together. This is 1/4, and this is 1/2. I can't directly add them together. It doesn't make sense, because if you look at the size of my pieces, this is a little piece, and this is a big piece, right? I mean, if we were splitting this thing up and we only had two pieces, you know, which one do you want, the little piece or the big piece, right? Doesn't make sense to try to add them together. So what we have to do is manipulate one or both of the fractions in order to give myself the same number of pieces in each pie. Okay, and this is, of course, an easy little analogy with the pie chart. Okay, when the numbers get bigger, you can't really draw a visual, but it's the same idea. I need to reslice one or maybe both pies so I have matching number of pieces. So you can see, if I simply cut this pie again here, now all of a sudden what I was calling 1/2, and it is 1/2, but now I can think of it as 2/4 instead, right? So I'm really asking myself, what is 1/4 plus 2/4? I have to have that matching denominator. And once I do that, we'll look at the visual. If I want to add these pieces together, I'm just going to consolidate them into one pie, right? I'm going to have 3/4. So we only add the numerators and we keep that common denominator, but we have to have the common denominator. And then we simply keep it, right? So that's our key to adding fractions. We must have a common denominator, and then we simply add the numerators, or subtract if it's a subtraction problem. Now you can get more than one whole pie here. You know, if I have 3/4 plus, well, even 5/4, that's a fine example. That adds another question here. I'm going to just add the numerators and get 8/4, but in this case, 8/4 is just 2, right? So I'm going to get 2 whole pies out of the deal. Okay, if I take 3/4 and 5/4, it's hard to visualize the 5/4 maybe. 3/4, we got that, 3 of them. Well, a whole pie would be 4/4. But I had one extra fourth over here, you know, there, okay? So if I consolidate everybody, what am I going to do? I'm going to take this piece and just plunk it over there, and I'm going to give myself 2 whole pies. So it makes sense. All right, so addition and subtraction requires that. If I'm doing mixed number, kind of same drill, you know, 5 1/4, let's say, minus 2, I'll subtract this time. 2 3/4. Now, if you leave them stacked as mixed numbers, and some texts are going to do this, okay, it requires you to kind of think of old school borrowing. You know, let me write them vertically. If I want to subtract, I'm subtracting 3/4 away from 1/4. And you're like, wait a minute, I can't do that, because 1/4 is smaller than 3/4. So you have to borrow from the whole number 5, right? And I'm going to borrow from that 5 and call it a 4. Okay, so what did I borrow? I borrowed a whole value of 1, but I'm going to call that whole value of 1 4/4, right? Because 1 is the same as 4/4. So I just borrowed myself 4/4, so that made that 5/4. I don't prefer to do it this way, I'm just showing. So I had to borrow from the whole number to give myself a fraction here. Now I can subtract the 5/4 minus 3/4, it'll give me 2/4. And the 4 minus 2 is 2, and then I'm just going to reduce now. 2/4 is 1/2. 2 1/2. I prefer just to turn them into mixed numbers, personally, okay, when I'm doing it by hand. So how would I turn that into mixed numbers? It'd be 21/4 minus 8. That's going to be 11/4. Okay, so now there's no borrowing or anything. It's simple subtraction. 21 minus 11, I'm going to get 10/4. Which I can reduce to 5/2, which I can turn into the mixed number of 2 1/2. All right, it just, to me, it's a little easier that way. Of course, we got the good old calculator here. 5, fraction button 1, fraction button 4, minus 2, fraction button 3, fraction button 4, 2 1/2. Okay, all good. If we don't have a common denominator, okay, we must create one. We must reslice the old pie. Otherwise, it makes no sense to try to add those pieces together. Okay, sometimes this is a time-consuming process. Okay, again, this is one where we'll jump to the calculator on the exam for sure, right? But I want to just talk about how to do it. We're going to have to reslice, in this case, both of the pies, because I can't turn a 2 into a 3 or a 3 into a 2, so I'm going to have to manipulate both of these denominators. Now, there's a technique to find what we call the lowest common denominator. It involves a prime factorization of each one, which in this case is easy, but when the numbers are bigger, it gets a little more involved. But there's kind of a surefire way to find the lowest common denominator, and that's you grab each denominator off to the side and you just start counting multiples of that number. So 2, 4, 6, 8, 10, 12, 14, 16, 18, blah, blah, blah. Do the same thing with the 3. 3, 6, 9, 12, 15, 18, blah, blah, blah. The first time I hit a match, what's my first match? 6. That's my lowest common denominator. Okay, now you notice I hit other matches. I hit a match at 12. I hit a match at 18. I'm going to hit matches all along here. Well, we want to find the lowest common denominator. All right, so I want to change both of these fractions into denominator 6. So I ask myself, how do I do that? Well, if I multiply 2 times 3, I get a 6. So I'm going to do the same thing top and bottom. Otherwise, it's no longer the same value. I'm now unreducing these fractions. We've reduced fractions. Now I'm going to unreduce. And here, to make that a 6, I got to multiply by 2, top and bottom. So this is really 3 over 6 plus 2 over 6. I've got that common denominator. I add those numerators, 5 over 6. Okay. You can always give yourself a common denominator by multiplying the two denominators together. Now, in this case, 2 times 3 is 6. It happened to be the lowest, okay? But that's usually not going to be the case. You're usually going to give yourself a larger denominator when you do that, okay? What if we did 1/4 minus 1/6? Okay, well, you say 6 times 4 is 24. That's a common denominator, and it is, but it's not the lowest. If I start counting multiples of 4, 4, 8, 12, and I start counting multiples of 6, 6, 12, I got one at 12. So that'll be better. Okay, why better? Well, let's do it both ways. Let's convert it into 12s. So I'm going to multiply by 3, by 3, by 2, by 2. 3 12ths minus 2 12ths equals 1 12. I'm done. I don't have to reduce. Okay, now I might have had to reduce. You're not guaranteed to not have to reduce just by using the lowest common denominator. But if I had used the 24, I most certainly would have to reduce because that's not my lowest common denominator. It's an easy way to get it. 6 times 4 is 24. You just say, I'm going to deal with it. Well, I got to multiply this one by 6, this one by 4. So I'm going to get 6 over 24 minus 4 over 24, which is going to give me 2 over 24. But I have to reduce 2 over 24. And that, of course, reduces into that same 1/12 we got. So it's not wrong to do it that way. It's just not really preferred or recommended because you're giving yourself extra reducing to do. Okay. Mixed number, kind of same story. We did one there. Adding, subtracting is really the same business. You have to. I just prefer to convert them to improper fractions, so you're not worried about borrowing and things like that and carrying. I just prefer to treat them as mixed numbers personally, and do it that way. So let's run through an example there. One more, I should say, example. Let's do a subtraction here. What do we do? Is that subtraction? Buzz. Yeah. All right. So whatever. We'll do another one. Yeah. You know what? We'll do this one with the old calculator. Because I know you guys, you can't fool me. You're going to use a calculator on the exam. Okay, and of course, I do not blame you whatsoever with the clock ticking on the exam. You need to get this done as quickly as you can. So what do we got here? 2. Now I hope the jury is still out on, as I record this video, which is December of 2020, the jury is still kind of out on what calculator you're going to be using depending on when you take this test. But the one I'm using here, as I maybe I've mentioned, is the one that they told me you get to use. And but some students are taking this exam at home with the COVID, and they're using probably just their own calculator. But if you're coming into the testing center, I think this is what you're going to get. All right, so it's got a nice little fraction button, 2 7/15 minus 1 4/5. Okay, so we will just shortcut the answer. Not even a whole mixed number anymore. It's strictly a fraction of 2/3. Okay. Okay, let's see. Let me just flip here a little bit and make sure. I think that's going to probably do it with fractions. Our next video, we'll talk some more about decimal and percent type stuff, but that should probably do it with the fractions. So let me end this one here.